In this lesson, we're going to start our chapter 8 on square roots and radicals. All right, so square roots played a real important role in the development of mathematics, and it kind of goes back to about 300-400 BC with a guy named Pythagoras, who was a Greek mathematician, and in the Greek mathematicians were thought of almost as gods, almost meaning that if they said something was true, then it had to be true. And so Pythagoras said that all numbers were rational numbers. A rational number means a number that can be written as a ratio, basically whole numbers and decimals. So one day, one of his students came up to him and said, "Hey, what if we have a square with an area of 1? What would the length of the side be?" Well, the side would have to be 1 because we know the area of a rectangle is length times width. Okay, well, what if we have an area with a square of 4? What's the length of that side? Well, that square would have to have a side length of 2 because 2 times 2 is 4, right? Of course. So what if we have a square with an area of 2? Oh, well, what happens there? Well, is it 1? Is this side length 1? No, because 1 times 1 is 1, right? Well, okay, maybe it's 2. Well, if it was 2, if both the sides were 2, 2 times 2 is 4. We're trying to get an area of 2. That doesn't work. All right, well, so what if we have 1.5? Well, 1.5 squared is 2.25. Ooh, that's a little bit too big still. All right, so let's drop it down to 1.4. That gets close, and we can play this game we go back and forth. 1.41, oh, that's pretty close. We could do 1.414. That's really close also. It turns out that 1.414 squared is about 1.999. That's pretty close, but not quite there. Moral of the story is this: we get what we call an irrational number. So this keeps on going. It's never going to end and never repeat. Okay, this is what we call irrational. All right, that's going to play a real important role. So we have a name for it, and we can find the number better by using what we call the square root of 2. Here, the square root of 4 is the number that makes that finds the side of the square. That's 2. Here, the square root of the area, square root of 1, is 1. So we had a side length of 1, a side length of 2. Well, the side length here is the square root of 2, which is about 1.414 if you use your calculator. All right, so we write that as a radicand. We have a name for it. We're going to call that number the square root of 2. That is what we call that. And so we have this little squiggly thing right here. This little symbol right here is called the radical. That's a radical symbol. And this number on the inside, that's called the radicand. All right, we don't use that word a lot, but sometimes it's useful to have a name or a term for that number inside. So every non-zero number has 2 square roots, okay? So, for example, the square root of 36 is 6 because 6 times 6, or 6 squared, is 36. Is there another number that we can square to get 36? Well, what about negative 6? If we take negative 6 and we square it, we get 36 also. So there's 2 square roots, a positive square root and a negative square root. Now, often we just want the positive square root, and we have a name for that. We call that the principal square root. The principal square root of a is the positive number b, that such that b squared is a. All right, so that's that number that we can square to get a. So the square root is the number that we can square to get the number inside. All right, so let's just kind of cruise through some little examples to see how a square root kind of works. If we have the square root of 9, well, that's saying what number times itself equals 9? And that's 3, because 3 squared equals 9. Okay, we can square root whole numbers like that. Can we square root decimal numbers? Sure. The square root of 49 is, or 0.49 that is 0.7, because 0.7 squared is 0.49. Now, in this case, we have 0.49, the square root of 0.49 is 0.7. And because of this negative right here, we're going to take that and our answer will be negative. Whoa, big old negative. Negative 0.7. All right? What about fractions? Can we square root fractions? Well, sure we can. We can square root those fractions. We can say the square root of 36 is 6, and the square root of 49 is 7. And 6/7 squared means 6/7 times 6/7, which 6 times 6 is 36, and 7 times 7 is 49. Remember, when we're multiplying fractions, we just multiply straight across. All right, so this is 6/7. That's our answer there. So we can square root fractions. We can square root decimals. We can square root whole numbers. All right, all kinds of things we can do with square roots. Well, we have to think about the order of operations. Square roots act kind of like parentheses here. So in this case, we've got to do the stuff inside the square root first if we're evaluating this. And 100 minus 36 is 64. And we ask ourselves, what number multiplied by itself equals 64? And that is 8. Okay. Well, what if we take a similar looking one here? Let's see what this comes out to be. Now notice the minus here is not inside the square roots. So we're going to square root 100, and that's 10, because 10 times 10 is 100. I'm going to copy down that minus sign, and the square root of 36 is 6. And what's 10 minus 6? Well, that's 4. All right, so we get two different numbers here. So notice the square root of 100 minus 36 is not the same as the square root of 100 minus the square root of 36. Okay, so if you see this right here, don't go trying to square root both of them first. You got to subtract first and then square root. All right, we're all going to be tempted to do that at some time, so watch out. So what about negative numbers? Square root of negative 16. Well, that means we need to find some number that we can multiply by itself to get negative 16. Is it 4? Is 4 squared negative 16? No. Is it negative 4? Well, negative 4 squared, notice I wrote in parentheses because we're taking negative 4 and we're multiplying it by itself. Well, that means negative 4 times negative 4. Is that 16? No, it is not. I'm going to put a slash through that equal sign. So there is no number that you can multiply by itself to get negative 16. So this does not have an answer. So we say this does not exist. All right. Or we're going to use an abbreviation for that, exists, if we can spell. We're going to call that DNE. Okay? Sometimes we also say that there is no real number that we can square to get negative 16. So, but for this class, most of what we're going to be saying is does not exist. Okay. Great. Well, a couple more things here. All right. So what if we have the square root of 5 squared? Well, what is 5 squared? 5 squared is 25. So what's the square root of 25? That is 5. Okay, great. How about the square root of negative 5 squared? Well, over here, 5 square root of 5 squared just kind of canceled and we got a 5. So I wonder, are we going to get, is this going to come out to be negative 5? Question mark. I'll put a question mark there. Well, let's find out. When I square negative 5 here, negative 5 times negative 5, and that's what negative 5 squared means, is positive 25. Okay? So, all right. So positive 25, and the square root of positive 25, it's that principal root that we learned about earlier, the square root of 25. Notice that's the same thing. Is going to be not negative 5, it's going to be positive 5. So here the 5 came right out. Positive 5 was what we started with, positive 5 is what we end up with. Here negative 5 is what we started with, but we ended up with positive 5 because it's a principal square root. It's got to be positive. So with that idea, now let's talk about variables. So what's the square root of x squared? Well, we don't know what x is, but we know that when you square and square root, they kind of are inverse operations. They cancel each other out, and we get x. Well, is that always true? Does the number we started with, is that what we come out with? Well, it is if it's positive. If it's positive, like this positive 5, then positive 5 comes out. But if it's negative, it comes out to be the opposite. In other words, the numbers that we always get out comes out to be positive. Do you remember from a previous class what makes a number always be positive? Hopefully you're thinking of absolute value. So these symbols here are the absolute value symbols. So the absolute value of 5 is 5. The absolute value of negative 5 is 5. So absolute value takes a number and makes it positive. If it already is positive, it stays positive. All right? Okay, so there's a basic idea of what a radical does.